You worked a problem yesterday where I had told you that a man was pushing a car because he ran out of gas or something. Something happened to the car. And I told you to ignore friction. And I don't know if you noticed those two little words in there or not, but if you did notice them, you probably went, seriously, Mrs. Thompson? You can't ignore friction. I mean, if you could ignore friction, things would be really easy to move all of the time, and guys would have no trouble pushing cars because it'd be like if they were on an ice rink or something. You give them a little shove or lean against them, and then they'll move just fine. But in reality, friction is very much a part of our lives. And while sometimes we don't like it, there are other times it's going to be exceedingly helpful. The first thing I want to talk about, though, is why we have friction. And I want you to put on your imagination for a second and think about what the surface of an object would look like down at the atomic level. Okay, so atoms are organized, and again, this is something we'll talk about more when we get into chemistry a little bit later in the year. But the way that an atom is organized is it has a very, very dense middle. All of its protons and neutrons are in the middle of the atom, and then the electrons are kind of zooming around the outside in different places. Okay, and so an atom is really made up of a lot of empty space. And so when you have an object and you have a lot of empty space within the atoms of that object, it's almost as if the edge of the object isn't smooth, even though it may feel like it to our fingertips, but in actuality, it's a very bumpy type of surface. So let's say that this right here is the surface of a box, or the surface of the floor. And let's say that I have a box sitting on the floor. And so all of these have their little atoms sticking out. And because there's so much empty space, it's not really nice and smooth because of all the extra space that is in those atoms. And so what happens is that when it sits on the floor, the atoms kind of sit down next to each other, and they kind of interlink in with each other, kind of like my fingers are doing right now. And so when you go to try to move an object, it's hard to get it started moving because all those atoms have kind of sunk into each other and kind of started gripping each other almost, is kind of one way to think about it. So once you get it started moving, you kind of dislodged all of that. And so then at that point, then they're just kind of catching on each other as you're shoving it along, but they're not really sunk down quite as far. And so that's why it always takes more effort to get something started in motion than it does to keep it moving once you've got it moving. Okay, so there are actually 3 types of friction, and all of these types of friction are going to move in a direction opposite to the motion. So remember, friction is a force, and so if you push an object and the object starts moving that direction, then the force and the motion have happened in the same direction. But if you shove a box on the floor, the box may start out fast, but eventually it slows down. So the motion is this way, but the frictional force is going to actually shove in the opposite direction and make the acceleration one that it's going to be negative. You're going to make the object slow down because the force is acting in the opposite direction as the motion is. Sort of like when you apply brakes to something. When you apply brakes, you're forcing it to slow down. When you apply a frictional force, it all too is going to make the object slow down and not continue moving as fast in that same direction. Okay, so 3 types of friction. The first is rolling friction, meaning the object has wheels. You guys know as well as I do that if something has wheels on it, it's a whole lot easier to push than if it does not have wheels. Now, we're not going to deal a whole lot with rolling friction in this class, but I definitely wanted to mention it. It is mentioned in your book, and obviously something that's going to roll is not going to exhibit the same amount of a frictional force as something that does not have wheels. These other 2 types of friction, though, we're going to be dealing a lot with them. The first is sliding friction, and sliding friction opposes motion once the motion has started. So that's where I was talking about, where once you've kind of got the object dislodged, it's kind of bumping along. The objects or the atoms in the floor are bumping along with the atoms in the box or the object that you're trying to scoot. And so they bump, and they're making the objects slow down, but it's not nearly as strong as static friction, where the atoms have really settled down into each other and it's hard to get that object to move from the beginning. So of these three types of motion, if I go down this direction, this is where they are increasing. So rolling friction is less than sliding friction is less than static friction. So for example, if I gave you two numbers and I said, I have an object sitting here and I have 150 newtons that I know is either sliding or static friction, and then I have another force that's 300 newtons, and I want to know one of those is either sliding or static friction, but I don't know which one is which. Well, which one would be which? Well, you can tell because static friction is always higher. It's always harder to get something moving than it is to keep it moving. So if these are the two numbers you have, then the higher number has to be the static friction and the lower number has to be the sliding friction. Again, it's harder to get something moving. You'd have to apply slightly over 300 newtons of force to get it moving. And then if you want to keep it moving, you only have to apply 150 newtons of force. Now, these types of numbers are going to change depending on what two types of surfaces you're looking at. Are you dealing with silk? Are you dealing with cardboard? Are you dealing with bricks? What type of surface are you talking about? What are you trying to slide it along? Do you have a concrete sidewalk? Do you have grass? Do you have a nice smooth floor? Do you have carpet? And so what type of surfaces are we discussing there? And so those numbers for sliding friction and static friction will change depending on your surfaces, but it doesn't matter what the surface is. Static friction is always bigger than sliding friction. So you'll have a number of homework problems today where you're going to be practicing understanding the difference between the two of them.